Welcome back to my YouTube channel, folks. So today is the last day of June LeetCode challenge, and the question is very interesting. So the question is word search 2. So this is the question in which we can demonstrate a very useful data structure that is called Trie data structure. So Trie data structure is a data structure in which every node is stored a string, and we can search for prefix everything. Like we can also say that Trie is basically an array tree in which we can store words inside our many words, billion of words inside this data structure. So this data structure is very efficient to use for search, to insert, and also search for some prefix, etc. This can be used in various use, like this is very useful, like this can be used in Google search system, search suggestion system, like this can be used there. So first of all, we have to see what is try. So in LeetCode there is a exercise on Trie data structure. So we can go there and we can see things, how we can implement our Trie data structure, how we can insert in a Trie, how we can search in a Trie, how we implement the whole Trie. Trie is also known as prefix tree. So each word, by definition a Trie is a special form of an array tree, typically a tree used to store strings. Trie used to store strings. Each Trie represents a string. So for example, this is a Trie. Here is an example of Trie. So am, uh, am, am. So this whole word is am. Then this whole word is bad. Then this whole word is b. Then this whole word is so. So in this way we can store everything in a data structure. Like every alphabet is in between A to Z. So there is total of 26 alphabets. So this is very efficient data structure for storing for every dictionary. Like bad, for example, in this example, bad, bad. So here bad and be, we can store both b in the same node. Like we can use b in the same in the bad also and b also. So this is the magic of Trie data structure. So let's see what question says. Okay, let's draw a Trie first to demonstrate the idea behind Trie. So let's suppose I have two words, that is b. Sorry about my handwriting because I am using touchpad. B and B E D. Bed and b. So we can store in Trie data structure in this way. So first this is the root node, then b. So we have at first we have to store b, and we have a key value that represent if this whole word is comes to an end or not. So in this way we can see if the word is there or not. Like we have to initialize this whole to false. So b for false because there is no word. Then again be, be, be. So this is e, sorry about it. And also be is also not, in this word. And now we can go to BEE. So BE, true, because here the word comes to an end like BEE. So we have to check R key to true. And now for D, this is D. So this is D, and we have to put our key to true. So in this way we can draw our tree data structure BEE and BED, and this is our root node. So we can also write BE because BE is also a word. So in the so BE, so for that we have to put it this to true. So BE, so B is a word, B is a string, then BE is a word, and BED is a word. This is D, okay. Sorry about my handwriting because I am not used to virtual whiteboard and stuffs. I think I get used to in some time, I think. So in this way we can implement our trie data structure. You can go through this explore section to learn more about trie data structure. Trie data structure is very important data structure for dictionary and stuffs, for very efficient use. So we can implement our trie data structure in two ways, one by the help of hash map and one by the help of array, because there is only 26 alphabets, so we can use an array of 26 size 26. So now come to this question, word search 2. So the question is, given a 2D board and a list of words from a dictionary, so find all the words in the board. So there are so many words, there is a board, 2D board. We have to find the exact word that can be there in this dictionary. We have to find that those words, sorry. So for example, eat is there because EAT, eat. So eat is there. Then oath, OATH is also there, because we have to go to adjacent cells only by horizontally or vertically, not by diagonally. If we can go to diagonally, then we can go to 8 directional also, but in this question we have to go in only 4 direction, upside and horizontally and vertically, so OATH. So this is a word in our dictionary, so the output is oath. We have to store this in our output array. Then EAT is also in the dictionary, so we have to add it to our array. So we have to use, so are you getting it? So we can find we can use trie data structure, because trie data structure is a perfect data structure for this question, because we have to search word, and for searching in trie it is very efficient to use trie, and also search and insertion. So first, so the algorithm is, we have to use two method. One is backtracking or DFS, and other is trie data structure for storing all the words. So trie data structure can be used for storing all the words, and we have to see all the possibilities, like all the possibilities, like horizontally, or the possibility in the horizontally direction, for example OA, for example for T. So uh, we have to see all the possibilities in 4 direction. So first we can go to TA, that is not a word. then TAE, that is not a word, then TE, then TH. In this way we can explore all the possibility of that data structure. So after this, uh, first we have to take in backtracking. We just have to we have three operation, as you see in my last previous videos. There are three components of backtracking. First we have to visit, then operate, then take back our value. So in this way we can solve this question efficiently. So the code is, so this is the implementation of trie data structure. So let's see the code. So for as I said, for key value I have to initialize the key value to false, and there is an array of 26 character that is known as child. Then in the class trie, I am initializing a trie node root, uh, root that can be used as a root. This is the root of this data structure. So this is the root. Then I have to I have to I have to insert all the words to my trie so that I can search it efficiently for my DFS algorithm. So I'm adding all the words to trie by the add word keyword. So the in the insert function, that is add word. So if there is no last node, like there is no child, like in this example BE. So in this way BE, after implementing BEE, so BEE, so there is no node of D, there is no child of D, like after E there is first we have no node of D, so we have to add this D to our trie node so that we can access, we can insert it to the our trie. Yeah, this in this way we can insert the whole trie. You can go to this article to read about implementation of trie, and at last of every word we have to check that this is a word, and check the key that is true. In this way we can able to check if there is a word or not. So this is all about trie. So now I have to implement DFS or backtracking. So for every node we have to check every possibility. So DFS, I am using board, ij, root and hash. So I'm first adding all the words in my trie data structure, then I'm accessing the root by the get root method. So get root method basically return the root of that of my trie, and hash function is basically uh, for, because set is there is no, we can't have revisit all the nodes. So I'm using a hash set for that, because a hash set is the data structure in which we can add it to twice, but there is no duplicates in the hash, so we have to check for duplicates also. So I'm using set for that. So in this DFS method I'm just this is the normal check if there is out of bounds or not. If there is out of bounds, then we just have to return. And then if there is a child, like I have to see if B is there or not. If B is not there, then I simply return it, and at last we see return that word. So now I have to add it to my current string, the first word, like I have to add from O, current string O. first word. Then I have to go to the child, child of OATH. So OATH, O. So in try, O, visualize this, O, then A, T, H. So A is there, so I have to go there. So A, so I have to see all the possibility and see if A is there or not. So A is there in in this direction, in the horizontal direction. So in this DFS, I have find my OA. Then in the same way, T, I can find T and H. In this way, I can insert it to my word. So if there at last, if there is root is key, so if the key is true, then we can say that we have found our array. We have found our word that is present in our dictionary. So basically, we then just have to insert it to our cur and move to our next round. So I am using a space bar putting to this, because of this is a backtracking approach, as I said. So this is basically for visited nodes, because there is a lot of possibility that we can revisit the same node twice. So in this way we can not visit the same node twice. And at last I am getting back my initial result. That is the basic three approaches of backtracking, like 3 steps of backtracking. So this is it. This is my word search 2. This is my one of the favorite question. I came across this June challenge. So hope you like this video. Comment, like and subscribe, and don't forget to pick the bell icon, so that every time I upload the video, then you will be notified for that. So thank you. I'm improving, I think. Thank you. Bye.